Hello grade 10, Mr. McMahon here. Happy Ramadan to everyone. You can see my lovely decor above. So just to give you a rundown of week 6, we will be looking at modelling trig functions again, but using the GDC and looking at a real life application as in the Ferris wheel. So you'll be able to see that in the assignment. I put some links up for the great Eddie Wu, who'll be able to help you out with that. I'm going to run through an example of exercise 13L and show you how to do it on the GDC and also by hand. And from there, we should hopefully have a fun week ahead, not too heavy for you. I know it's Ramadan and all of you complain so much work, but you are in the 10 extended, so I expect us to keep the pace up. Hello grade 10, I'm going to run through exercise 13L with you, looking through the GDC and also looking at how you could do the calculations by hand on paper. So we're going to run through A, B, C and D, and hopefully with this knowledge you're able to apply it to the later exercise 13M. And then our little project over the next 2 weeks is going to be related to the Ferris wheel. So for exercise 13L, you're going to want to take your GDC and obviously put in the information. So here's my data that I've already typed in for question 2. So I've jumped ahead a step, I've graphed this function on the same axis, and I'm going to use the regression function on your GDC to get a sine model. So you can do these, you can either do C and D first, then A and B, or A and B then C and D, it doesn't really matter. So if I do C and D first here, you can see question 2 here. Then go to my graph and I've got my X and Y axis, all my data in, and then I'm going to go home and I'm going to go to the bar chart, the purple app, which is here. We're all familiar with this from regression. I'm going to add my X variables, then I'm going to add my Y variables, and you can see that it makes some sort of trig function there based on the data given. So now all I have to do is menu, analyze, and then I want to do the regression of this. Now it's not a linear, it's not a quadratic, it's not a cubic, it's not quartic, it's not exponential, it's not a log function, but it is a trig sinusoidal function. So I'm going to choose that one, and you can see that it gives me a function y equals 6.33 sine bracket So that gives me the model of this function in terms of sine. So that is all you have to do for part C and D. Then you would take a screenshot of this and put it into your evidence folder. For part A and B, you have to do it by hand. So you see it wants it in the answer of y equals a cos bracket b x minus c, or b bracket x minus c close bracket plus d, which you should now be familiar that a is the amplitude, b is the number of periods of the cycle, c is the horizontal shift, and d is the vertical shift of the trigonometric function. So how am I going to find out all these letters A, B, C and D based on just a table of numbers? Well, if you remember the calculations, to find the amplitude, we want to take the y values. So we have to look at the y values for the amplitude, and the amplitude is going to be the big minus small. So where is the big number? The big number is 21.9 minus the small number, which is 9.3, so that's the maximum and the minimum point, minus them on the numerator, and then I'm going to divide it by 2. So that should give me my amplitude. How am I going to get the vertical shift? Well, that is going to be your middle point. So the middle point between the maximum and minimum. So to get the middle point between any two numbers, you take your maximum, which is 21.9, and you add your minimum. So 21.9, add the minimum 9.3, and divide it by 2. And that's going to get my shift. How do I get the B? Well, the B part is the number of cycles. So if you think about the period, B is equal to 2 pi over the period. So if you think about that, well, if I look here at 25, the maximum is 21.9. And if I go to the next time it's 21.9, it's at 55. So that means that one cycle is between 55 and 25. So that means that one cycle is 30. 55 minus 25 is 30. So one cycle between 21.9 and the next 21.9 is 30. So if I want to work out B from there, what do? I do 2 pi or 360 divided by 30. Okay, and we're going to use 2 pi as our radians. And then the last one is the horizontal shift. Well, this is related to cos. So if you remember the cos graph always starts at the maximum. So the cos graph at 0, the original cos graph starts at 1. So when x is 0, y is 1. So we need to find when is the first maximum. That there is going to be our horizontal shift, C. So from 0, when is the first maximum? Well, the maximum is 21.9. And what is the x value of our first maximum? It's 25. So that means that our horizontal shift is the first x value of our maximum data. Okay? And then once you've written your cosine function and you've got your sine function, if you put them in, if you put your two functions in to your original graph, you will get the same graph output. So I would just go here, here, I would put in my cos function, which I've calculated by hand. I would put in my sine function, which I've got through regression, and you should see them overlap each other. And that will be you to check that you're correct. Okay, thank you all. Let's look forward to hearing from you soon.